Our sun, the heart of our solar system, is a dynamic star. It is not a quiet, gentle giant. The sun is a churning, boiling ball of plasma. On May 14, 2025, the sun put on a fiery show. Two powerful solar flares erupted from its surface. These flares sent bursts of energy towards Earth. These events were a reminder of the sun's power. They also reminded us of the sun's influence on our planet. Scientists around the world watched these events closely. They wanted to see what impact the flares would have on our technology and our lives. The flares were a spectacular sight. They were captured by telescopes, both on Earth and in space. The images showed the raw power of the sun. They also showed the beauty of these celestial events. Solar flares are intense bursts of energy from the sun. They happen when magnetic energy builds up in the sun's atmosphere. This energy is released suddenly. Think of it like a rubber band snapping. The energy travels at the speed of light. It reaches Earth in just 8 minutes. Scientists classify solar flares based on their strength. The smallest are A-class, the largest are X-class. The May 14th flares were significant. One was an M-class flare. The other was an X-class flare. The X-class flare was the most powerful of the year. The X-class flare was particularly impressive. It caused a radio blackout on Earth. This blackout disrupted communications in some parts of the world. It was a reminder of how vulnerable we are to space weather. Solar flares can have a variety of effects on Earth. One of the most common is radio blackouts. These happen when the sun's radiation interferes with our planet's ionosphere. The ionosphere is a layer of our atmosphere. It helps to reflect radio waves. The radio blackout on May 14th was classified as an R3 event. This means it was a strong blackout. It affected high-frequency communications. These are used by aviators and maritime operators. The blackout was felt across Europe, Asia, and the Middle East. In addition to radio blackouts, solar flares can also cause geomagnetic storms. These storms happen when the sun's energy interacts with Earth's magnetic field. This can disrupt power grids, satellites, and other technologies. The sun goes through an 11-year cycle of activity. During this cycle, the sun's activity waxes and wanes. The peak of this cycle is called solar maximum. At solar maximum, the sun is more likely to produce solar flares and other space weather events. We are currently approaching solar maximum. This means we can expect more solar flares in the coming months and years. Scientists are closely monitoring the sun's activity. They are working to improve our ability to predict and prepare for space weather events. The recent solar flares are a reminder of the sun's power and unpredictability. They are also a reminder of the importance of space weather research. By understanding the sun, we can better protect ourselves from its potentially harmful effects.